Okay, so orbitals are represented by this blank line. It will normally have the label underneath of it of what orbital it is, like 1s. Okay, it would say that underneath about what orbital it is, what we're trying to fill. Okay, so if you see a 1s orbital like this, that means it has no electrons. Okay, it contains no electrons. An orbital that has one electron is represented by this, just with one arrow. Okay, and it doesn't really make a difference as to which direction the arrow is pointing. We just have to realize that when we have two arrows, they have to be pointing opposite directions. Okay, so these arrows right here are electrons. That's what they're representing, electrons that are filling these orbitals up. Okay, and really in real life they should be drawn with only one little half of the arrow tip like that. But I couldn't get my PowerPoint to do that. Okay, so we just draw them with one little half arrow tip. Okay, so if something has two electrons, that's how it's notated. If it has two electrons, how many more electrons can that orbital hold? None. Each orbital can only hold two. Okay, so let's say for the p's, how many electrons do we know those can hold? 6. So that means there'd be 3 lines here, and they would underneath it would all say 3p. Or 2p or whatever, okay? And so we'd fill them one by one like this, and then we would go back and fill them opposite, okay? So we have to fill them one at a time, and we'll talk about that here in a little bit. Okay? Questions?
What was the half arrows again?
Now we're going to move on to talking. Yes, sorry, Dylan.
When you're going like on S's, do you use the 2 arrows, or do you like use 1 arrow twice?
You use 2 different arrows. You use one up, one down.
Okay.
Yeah, for every orbital they have to have opposite spin. So we talked about that yesterday a little bit, that if you have electrons paired in an orbital, they have to have opposite spin. So the up arrow is spinning like positive, the down arrow is spinning negative. Okay? And that goes back to kind of the quantum numbers we learned about. That last quantum number we learned about was positive 1/2 or negative 1/2. Remember that? Kind of? That indicates that spin. So that's telling us positive or negative spin on that electron. Okay, we're going to move on to something called Hunds Rule. Hunds Rule tells us that orbitals of equal energy are occupied by one electron before any orbital is occupied by a second electron. So what this is telling us is that for those p orbitals that we talked about, if we have, let's say these are the 2p orbitals. Okay, so we know this 2p orbital can hold how many electrons? 6. 2p orbital can hold 6. So that's what we have to have 3 different orbitals. And remember we talked briefly about them being on the x, the y, and the z axis. Do you remember that? Briefly we talked about that. So we talked about them briefly being on these x, y, and z axes. Okay, so Hunds Rule says that we just can't start entering electrons. If we have 3 electrons we need to put in, we cannot put them in like this. 1, 2, 3. That doesn't work. What we have to do is we have to fill the orbitals first, put an electron in each orbital first, and then we can start going back and filling the second one in. Okay, so if we have 3 electrons that we need to fill, then we have to fill them like this. 1, 2, 3. Okay? If we get 2 more electrons that need to fit into these orbitals, where will they go? X and Y. And what direction will they be going? What spin will they have? Negative, exactly. Okay? So this would be at 2p what? 2p5. 2p5. Okay? So if that was our exact element, what element would it be? 2p5. Fluorine. Very good. Very good. Okay? So we see what we're getting at here a little bit? We have to fill them one at a time. Okay. All electrons in singly occupied orbitals must have the same spin state. So if we look at, again, these p orbitals, let's say, again, these are the 2p's or something. That means we can't put an electron here, and then the electron that goes here is the next negative spin, and then this one's positive again, and then we fill in. That's not how it works. When they fill the first orbital, that means they'll have the same spin. When they go back and fill the second, they'll have opposite spin. Okay, so this is a form of notation, a form of writing that. So we've got to make sure that when we enter them, the first three, they have the same spin. Make sense? Kinda. Okay. So let's look at nitrogen. Let's write the electron state for nitrogen. What is nitrogen's electron configuration? Okay, this is what it looks like. And I'm going to show you here, and then we'll do some practice, okay? And so this time they have little boxes drawn for orbitals. Most of the time you'll see just lines, okay? But we see 1s is full, right? We see the 1s would be hydrogen, helium. Those are full. 2s is full, correct? If we're looking at nitrogen's electron configuration, we know that 2s is going to be full. And then we have 2p3. Right, let's look at where nitrogen is on the periodic table. We see 2p3. So here we have one electron filling each of these orbitals. Here, here, and here. And we know that they're filling one orbital at a time, and they're all filling with the same spin. Yeah? Okay, this is called Hunds Rule. Hunds Rule tells us that we have to fill orbitals one at a time, and we have to fill them same spin first. Okay? Think you can do it by yourself now? Let's do some practice. What's the orbital notation for the following elements? Let's look at boron. So first what we do is we label our orbitals that we need to fill. What's the first orbital we have to fill? 1s. Next is 2s. Then this is 2p. Okay, does boron go any farther than that? No. Okay, so I'm going to put the electrons here in a different color. So our first orbital that we absolutely have to fill is what? Okay, 1s. And is it full? That means we put 2 electrons in there, opposite spins. Okay? When we're talking about filling electron orbitals, we don't fill 1s, 1 electron in 1s, then 1 electron in 2s, 1 electron in 2p. That's not how it works. Remember, we have to fill lower energy levels. And we know 1s is lower energy than 2s, which is lower energy than 3s. Okay, so when we're talking about filling one at a time, we're just talking about these 1s orbitals. And then we move on to 2s, and we fill those one at a time. Okay, does that kind of make sense? All right. So when we fill the 2s orbitals, are they full or not? Yes, so we just put them both in there. Okay? And then if we move to 2p, how many electrons are in the 2p orbitals for boron? 1. Okay? And since we've been filling our positive electrons first, that means we're going to fill a positive electron here for 2p. Okay? Questions? Yes, Ashley. It doesn't always have to be. That's just typically how it's written. Yeah. Good question. Okay. Let's do fluorine now. So first of all, we think about what block is fluorine in here? It's in the 2p. Okay? So that means we're going to have 1s, we're going to have 2s, and we're going to have 2p. All right, let's fill our electrons here. Are the 1s orbitals full? Okay, so we're going to fill those opposite. What about the 2s orbitals? Also full, good. What about 2p? How many 2p electrons are we going to have for fluorine? 5. So what we do is we fill 1, 2, 3, then we go back and we fill 4, 5. Yeah? Okay, do we see how we're filling these in? They have to be lowest energy first, so we complete the 1s, we complete the 2s, then we move through 2p one at a time. All right, let's try neon now. How are neon and fluorine going to be different? Yeah, it's just going to be, neon's going to have that final electron to fill its 2p orbital. Okay, so we have 1s, we have 2s, and we have 2p. All right, so let's fill 1s are what? Full or not full?
Yes.
Full. 2s are full. 2p we're going to fill how many? 6. So we're going to go 1, 2, 3, 4, 5, 6. It's important for you to realize that even though you know it's going to be full, it's a really good habit for you to get into putting electrons in 1, 2, 3, 4, 5, 6. Okay, that's really important for you to get that process down. Even though you know it's going to be a full orbital, it's important that you start realizing I need to fill them in one at a time at lowest energy, and then I come back and fill. Okay, does that make sense? So instead of just saying 1, 2, 3, 4, 5, 6, you take them 1, 2, 3, 4, 5, 6. Okay? That's just a good habit for you to get into. Okay, let's move on to one a little bit farther down the line. Okay, let's try sulfur. We see where sulfur is? Okay, so we're going to look at, this is called orbital notation. Or orbital configuration or something like that, okay? So let's think about what orbitals we're going to have for sulfur. 1s, 2s, 2p. Where else do we go after 2p? 3s. Then where do we go? 3p. Are we going to have to go any farther than that? Okay, so let me label my orbitals down here. 1s, 2s, 2p, 3s, 3p. Okay, and we'll fill in our electrons. So are the 1s orbitals full? Yes. Are the 2s orbitals full? Yes. Okay, what about 2p? We're still going to fill them in one at a time. Then we go back. Okay. The 3s. Okay. And why do we know that these beginning orbitals have to be full? Yeah, they fill as we go down the periodic table. So if we know that if what we're looking for is in the 3p's, then everything before that has to be full. Everything has to be full before that. Okay, so if we're looking at sulfur, how many p electrons should we have? We have 4. So we're going to go 1, 2, 3, and then where does my 4th electron go? Right there. Okay? So that's the orbital notation for sulfur. All right? You feel good? Feel like geniuses? Excellent.